And this lesson is going to match up to your book in lesson 4 or 5. We've looked at exponential growth before. This is going to be exponential decay. So the standards are going to be similar. We're going to find domain, range, asymptotes, zeros, intercepts, that kind of stuff. Now, and they're going to have the form of this: f of x is equal to a to the x. Now, in some of our stuff, we'll have b to the x. So p, that's just our base. And then we're going to look at some real-world phenomena. Basically, we're going to look at some real-world problems and that kind of thing with exponents. Now, if you look down here, this is going to be our essential question for this lesson. 5 years ago, you purchased a riding lawnmower for $1,600. Recently, you sold the lawnmower for $525. Okay, now we're going to assume the mower follows an exponential decay. With time, we're going to write a model for this and give the value v in dollars as a function of time. So after we go through the lesson, I want you to come back and try this particular problem. Now, before we get started, let's look at a couple of definitions. First of all, exponential decay function. If you notice, the function right here looks the same as a growth function. The only difference is here b, our base, and a has to be greater than 0, and b is between 0 and 1. Okay, and then b would be our decay factor in this case, because b is somewhere between 0 and 1. So it's going to be a fraction or a decimal. Okay, so let's look at an example. This is already worked out, so let me start over with this. Alright, so with this, what we're going to do is I'm going to show you how to plot this. Now, first of all, is it a decay or a growth? If you look here, we have 1/3 to the x power. So that means it's going to be a decay with our decay factor of 1/3. And then we'll find the rate of change. Now, we'll do more than asked here since this is our first example. But let's start out by getting some points. Now, we're going to do the integers from -2 to 2. So we have -2, -1, 0, 1, and 2. Alright, and then we're going to come up with the y values, which would be the range. So if I put in -2 in for x, okay, so since this is a negative exponent, if I flip it around, I can make it a positive exponent. So I'm going to end up squaring 3 and getting 9. Okay, I'm going to do the same thing with -1 so that I get 3. Okay, then when we put in 0 for x, remember anything with 0 power is 1. Then we're going to put 1 in, so we get 1/3. And then finally we'll have 1/3 squared, which gives us 1/9. Now we'll plot these points and come up with our graph. But before we do that, let's talk about our domain for the whole function. The domain can be any value of x, so it's all real numbers. Now our range is limited. Range, the lowest value that we can have with an exponential function, unless we've translated it, is going to be 0. So y has to be greater than 0. Now, so that's our domain, that's our range. Now our asymptote is the line that it will not cross. Now in this case that's the x-axis, but we define that as y is equal to 0. So that's the line it won't cross. Alright, so let's look at the graph. I'm going to draw a graph and then we'll discuss it. Alright, so this, I'm going to go ahead and we've got our coordinate, got our plane here, our graph. And what I'm going to do is I'm going to go ahead and put in the asymptote, which is this. Kind of go over the x-axis, because that's where y is equal to 0, and that's where it won't cross. So let's go ahead and plot some points. Alright, so at -2, we go up to 9. So somewhere up in here. And then at -1, we go up to 3. And then at 0 we're at 1, and then at 1 over here we're at 1/3. and then we come down a little bit, and so we end up with a curve that's going to come out here. And it'll never be 0. It'll get closer and closer, but it'll never hit 0. Okay, and so then that would be an idea of our graph. Now this is a decay because we're started out larger and then we're going down. Okay, so it decreases. Alright, so this function is going to decrease from negative infinity to positive infinity because you notice it's just getting smaller and smaller and smaller with this. Alright, let's look at another example. Here we have 3 to the 1/4. Now we're not going to plot as many points as we did last time. We're only going to plot 2 and use what we know about exponential decay functions, their graphs, to graph this. Alright, so let's put in 0 for x and 1. So if we put in 0, we get, for x, we get 3 times 1, so we end up with 3 here. And then when we put in 1 for x, we end up with 3/4. Alright, so given this, and that we know it's a decay, now our asymptote, I would go ahead and plot it to, that way we know what not to cross. Now for this, it's going to be y is equal to 0 for the line, so it's actually going to be the x-axis. Alright, so over here we're going to plot this. We're going to have x here, and then we'll have y. Now, I'm going to go ahead and draw in the asymptote. Now, our asymptote would be through here. Okay, it's going to be the x-axis. That's what we won't cross. Now, let's go ahead and plot the points. Let's go 0 would be up at 3, so go 1, 2, 3. Okay, and then at 1 would be at 3/4. So 1 and then 3/4. 3/4 is going to be somewhere in here. And then we know our graph's going to keep coming down. Should keep coming towards x, but not cross it. And then we draw our smooth curve coming out. Not too smooth, is it? Should come out this way and go up. So we have our decay function. Now our asymptote, again, is y is equal to 0, which is the x-axis. So our domain would be all real numbers. X can be anything. And then our range, okay, is going to be y has to be greater than 0. And we'll look at ones where they're not in a second. And then, of course, we're decreasing in this function over the as it goes from negative infinity to positive infinity.